ఒక 1 minute వెయిట్ చేద్దాం. కొంతమంది వచ్చారు. సో ఒక 1 minute వెయిట్ చేసి విల్ స్టార్ట్. సో ఎస్టర్డే మనం ఎక్కడి వరకు ప్రిపరేషన్ ఆఫ్ ఆల్కహాల్స్ ఫ్రమ్ డిఫరెంట్ టైప్ ఆఫ్ రియాక్టెంట్స్ నుంచి తెలుసుకున్నాం. ఫస్ట్ దాంట్లో భాగంగా from Grignard reagent, we already completed Grignard reagent. The second one from hydration of alkenes. So let's we start with the alkenes from preparation from alkenes, alcohols from alkenes. So this is the first one, hydration we already completed. Alkenes reaction with in presence of acidic medium hydration to prepare the alcohols. Most of them here we were preparing most of them secondary and tertiary alcohols. The third one by hydroboration method and oxidation of alkanes. So this method we are preparing primary alcohols also. This is also very important one. And the fourth one oxymercuration and demercuration. And fifth one hydrolysis of alkyl halides. And sixth one by reduction of aldehydes and ketones, amides and esters. And seventh one by hydrolysis of esters and ethers. And eighth one by formation of carbohydrates. Okay. So these are the important preparations of alcohols from the different type of reactant starting materials. Okay, we already completed Grignard reagents from Grignard reagent preparation. So now we start with the hydration of alkenes. Okay, from hydration of alkenes. So these are the alcohols preparation from alkenes. Different type of alkenes, different type of reagents, different type of conducting reactions on the alkenes to prepare the alcohols. So first we start with this simple example and hydration reaction. In this reaction, alkenes, acidic medium hydration to prepare the alcohols. Here, the water is a polar molecule. So what are the groups are present? H plus and OH minus. So the OH minus attack at the less number of the carbons. So less number of the carbons. So that's why the hydroxy group attached here. So that means, so we are getting always Markovnikov product. So that means the daily electronic atom attached with less number of carbon is a more stable compound. So that is the secondary alcohol we are getting in this preparation. Secondary alcohol. So here also same like that. So we are preparing secondary alcohol. The second one, reduction process in the help of sodium borohydrate to prepare the secondary alcohols. Third one, hydroboration. Hydroboration, we are using hydroboration BS3 and hydrogen peroxide, tetrahydrofuran. So these are the tetrahydrofuran is a solvent, and the hydrogen peroxide and BH3 is the reagent. So this preparation we are preparing the OH group at the terminal of the alkene bond. So that's why we are preparing primary alcohols in this preparation. It is very specific reaction to prepare the primary alcohols in this reaction process. So this is also one of the important process to carbon monoxide and hydrogen to reaction with alkenes to prepare the, first of all here we are preparing the aldehyde. After that we are conducting reduction process to produce this alcohol. So these are the methods to prepare the alcohols from alkenes. So different type of reactants, we are conducting different type of reactions on the alkenes to prepare the alcohols. This is also one of the important preparation. So the most important process preparation in this process is hydroboration. It is very useful to prepare the primary alcohols especially. So that's why it is very useful and it is very advanced one. So that's why we are this is one of the most useful reaction. Okay. So reduction of aldehydes and ketones to produce the alcohols also. This is also one of the important preparation of alcohols from aldehydes and ketones. So reduction of aldehydes and ketones respectively by powerful reducing agents like lithium aluminum hydride in dry ether produce primary and secondary alcohols. So first of all we see what is happening if in this reaction the aldehydes involving in this reaction to prepare the primary alcohols and the ketone involving in this reaction secondary alcohols preparation. For example, in acetaldehyde, so this is acetaldehyde reaction with lithium aluminum hydride to produce what is the product? This ethyl lithium hydride to produce in presence of acetaldehyde reaction with lithium aluminum hydride. So this is the acetaldehyde. Uh, we have two carbons in acetaldehyde and they undergo involving in reduction process to produce ethyl alcohol is the product. Ethyl alcohol is the product. So this is one of the best prepared to ethyl alcohol preparation from acetaldehyde. So this is also a very simple reaction conducting. We are using reducing agents like lithium aluminum hydride or sodium borohydride. These are the reducing agents we are using to prepare from carbonyl compounds to alcohols from. So this is the acetaldehyde from acetaldehyde to prepare um, ethyl alcohol. So for example, in case of acetone, what is happening? So let's we see what is happening if we are involving in this reaction acetone. So this is the acetone, 3 numbered carbons acetone. So involving in this reduction process, we are getting this 2-propanol. 2-propanol is the product. 2-propanol 2-propanol is the product. So this way we are preparing from ketone reductions involving reduction process to produce secondary alcohols and aldehydes involving in this process. Primary alcohols is the product. So these are the some of the preparation methods of the alcohols. Okay. So this is the hydroboration oxidation reaction. Here the alkenes and borane in presence of hydrogen peroxide to prepare in presence of basic medium reaction to prepare alcohols. So this way we are preparing hydroboration oxidation. What is happening generally in hydroboration reaction? So the carbon between the carbon, so there is no polar bonds between the carbon and carbon. We know about this because of the both are having same electronegativity atoms, carbon and carbon. So, but in depending on the stability, one of the carbon always the according to plus I effective, the more substituted carbon always positive charge is stable. If the less substituted carbon negative charge is stable. So that's why this carbon have positive charge, this carbon have negative charge. Especially in BH3, it is very different one. The BH3 borane. So generally, in borane, the BH2 has positive charge and BH minus hydride ion is negative charge. So that's why the H minus addition here, the carbocation and BH2 addition here. So so that's why after that, where the H2O2 peroxide reaction with this BH2 and cleavage bond between the carbon and boron to form the alcohols OH substitution. So at the same time the BH2 also uh, attached with the remaining hydrogen OH group. So we know about the hydrogen peroxide, we have the two OH groups are present. The general formula of hydrogen peroxide like this, H2O2. So that means OH and OH. So these both OHs are again addition one of the OH here. So to produce alcohols from in this process, again OH is attached with BH2 ion. So this way we are preparing this hydroboration oxidation reaction. So especially this is the hydroboration oxidation reaction is very useful to prepare the alcohols primary. Also we can prepare sometimes secondary alcohols. So that is it is involving in anti-Marconic rule. So that's why it is very important, useful preparation. This reaction under the basic condition. So sodium hydroxide is we are using as a basic condition reagent. Okay. So this is about the hydroboration reaction. So we will explain once again. So it is very simple reaction to understanding this reaction. Okay. Very simple reaction. In the carbon between the carbon, what is the bonding nature between the carbon and carbon? So that is the both carbons are same electronegativity. That's why there is no charges separation between this carbon. But um, according to inductive effective rule, the always um, carbocation, the carbocation that means positive carbocation, the most plus A group substituted carbon act as a carbocation. It is stable. So if the less substituted carbon, less substituted um, carbanion, less substituted are stable. So that's why this carbon act as a negative, this carbon as a positive charge. In BH3, so it is also very important one, the BH3. So what are the bonds between the BH3? Here the BH2 is positive and H is the hydride ion. Because of hydrogen is more electronegative than boron. No more electron than boron. So that's why the hydrogen negative charge hydride ion and formation BH2 is a positive charge. So this way here the less substituted carbon act as a carbanion. So this is the carbanion, this one carbocation. So the hydride ion attached here, the carbocation, and this positive ion attached in carbon carbon ions. So after that we are conducting hydrogen peroxide process to produce the primary alcohols is the product in BH2 between this cleavage. After that this is the alcohol we are producing. So this is the one of the important reaction of hydroboration oxidation reaction. Okay. So next one, oxidation, mercuration and demercuration. ఓకే, అది చూద్దాం మనం. మెర్క్యురేషన్ అండ్ డిమెర్క్యురేషన్లో కూడా కొంచెం ఇలాగే ఉంటుంది, కాకపోతే వీఆర్ యూజింగ్ దట్ ప్లేస్ వీఆర్ యూజింగ్ మెటల్ని యూజ్ చేస్తాం. So this is also one of the important reaction, oxymercuration and demercuration. And this oxymercuration and demercuration, what are the reagents we are using? First of all, um, when we learn about the reagents, so this is the mercuric acetate, OAC. OAC means acetate ion, CH3CO. So that is O minus. This one acetate ion. THF is a solvent. Tetrahydrofuran is the solvent, and H2 also solvent. So this is the sodium borohydrate. This is especially using for the reduction reagent. So these two steps, we are conducting these two steps. So to oxymercuration and demercuration to produce the alcohols from alkenes. So first of all, we learn about the reagents. So mercuric acetate and tetrahydrofuran is the solvent, H2O hydrolysis process. After that, hydrolysis process, and this is the sodium borohydrate reduction process reagent. So these are the reagent we are using in oxymercuration and demercuration reaction, especially, and alkenes involving in this reaction to produce the alcohols is the product. Alcohols is the product. Okay, చూద్దాం మరి alkyls. So this is the alkenes will be converting into alcohols. So they are R1, R2, R3 and R4 different type of substituted groups. So on the alkane substitution, alkane functional group. So finally we are getting the alkane. So this is also one of the important reaction, oxymercuration and demercuration. This reaction also always produce the hydroxy group substitution at the more substitution carbons. So this is also one of the anti-Marconic, follow the anti-Marconic rule. Okay. So the next one, this is the steps are involving in the oxymercuration demercuration process. So let's see how to understanding this oxymercuration demercuration the step by step. So here we know about the carbon. This is a positive, this one negative. So the acetate, mercury acetate, positive charge. So that's why this mercury acetate attached to this terminal carbon, because we know about the less substituted carbon act as a carbanion, the more substituted carbon act as a carbocation. So that is the principle. So according to inductive effect, so that's why the terminal carbon act as a carbocation, carbanion. So this metal acetate attached here. Because of this reason, attached here to produce this is the acetate ion bonding with. So after that, addition of water molecule. What is happening in water molecule? H plus and OH minus polar groups. So these polar groups are attached to this carbocation. So finally we are getting this product, mercuric product. So this mercuric product we are conducting hydrolysis process to produce the carbon between the mercury bonding, the carbon between the mercury bonding, the carbon generally, the carbon between the mercury. What is the bonding between carbon and mercury? The carbon, here the carbon have negative charge, the mercury has the positive charge. So where addition of water molecule, so H plus at carbon position and OH minus at mercury position. Finally we are getting this product HgAg, HgOAc. This is the byproduct we are getting, HgOA acetate and OH. So these are the byproduct we are getting from these reactants. So this is also a very important reaction to prepare the terminal alcohols, like the substituted alcohols at terminal position. So that's why this is also a very important reaction to prepare the mercuration and demercuration reaction. ఓకే, ఇంకేమైనా డౌట్స్ ఉంటే మీకు మళ్ళీ మనం నెక్స్ట్ క్లారిఫై చేస్తాను. మీరు వాట్సాప్లో కానీ అడగచ్చు మీకు డౌట్స్ని. ఓకే, థ్యాంక్ యూ.